In this short video, we're going to continue our conversation on our advanced refrigeration, and we're going to be talking about defrost and defrost clocks. These are probably the most important controls that you will find in commercial refrigeration, and they're probably the most misunderstood by technicians in the field. That's why we're spending so much time on these. Okay, so as we know, just as a quick review, the purpose of the defrost system is to take ice off the coil. Okay, ice is formed when warm, humid air comes in contact with the below freezing conditions of an evaporator coil. Now, in most refrigeration, people have to come in and out. The doors are open and closed, and that's what allows that warm, humid air into the system. So we have two types of defrost. Again, just to review, we have hot gas defrost. It uses a solenoid to reroute the discharged hot gas from the compressor to the evaporator, bypassing the metering device and the condenser. We also have electric defrost. It shuts down the compressor and the cooling system and energizes an electric heater. We have really two controls that are required to run the defrost cycle, okay? And one of them is sort of optional. So we have a defrost clock, okay? That's your main control, takes the system in and out of defrost. We also have a solenoid valve, okay? That's mainly used in hot gas defrost. So the defrost timer control, which is the defrost clock, initiates and terminates the defrost cycle. The defrost frequency times can be changed by adding, moving, or installing more set pins. Those are the pins on the outer dial if you think back to one of our last videos. We want to try to keep the cycle as proportional as possible, and you want to keep in mind customer busy periods. I do not want to put a system in defrost in a store or in a restaurant in the busiest time of the day where the door is always being open and closed. If we do, we're going to increase the temperature of that box and put a lot more load on the system and possibly damage product. The defrost time controls are the same controls are used for both hot gas and electric defrost systems. You do not need different timers. They're standard. Some timers contain a clutch solenoid. Okay, it's a defrost termination solenoid that will prematurely take the control out of defrost when needed based on coil temperature. We talked about the DTT, which is the defrost termination thermostat, and also the DTFCD, which is the defrost termination fan delay thermostat. So if we take a look at our different types of defrost timers, okay, this is one of the ones that's with it's a defrost timer with a solenoid. You see between pins 3 and X is your clutch solenoid. So pin 1 is our source voltage. Pin N is our other side of source voltage. I would say neutral, but sometimes you see these on 208 volt circuits, which is L1 and L2. Okay, there's a copper band installed between pins 1 and 2. Pin 3 goes to our defrost heater or hot gas solenoid. Okay, that's my normally open. And pin 4 goes to my refrigeration and evaporator fan motor circuit. That's my normally closed. So that is one type of defrost timer. Okay, and again, it's a defrost timer with a solenoid. Okay, another one of these, the pins are a little bit different, and that's why it's very important to look at the backs of these clocks when you first start service them, because you'll see where the contacts are. In this case, we've messed up, and we no longer have pin 1 as my line. We now have 3 and X. So again, be careful about that X terminal. It is not always your clutch solenoid. Okay, in this case, again, we still have the defrost solenoid with a defrost termination solenoid. Pin 1 goes to my defrost heater. Okay, so pin 1 is my normally open. Pin N is not neutral. It's my normally closed. If you put neutral on that N, you'll have a direct short circuit, so make sure you take a look. Pin 2 to 4 is my normally closed, and that's my refrigeration circuit. Okay. In this one, again, we have a defrost timer, but we have no solenoid, okay? So we do not, this is a defrost timer that's only time in and time out, okay? We don't have an early termination. So X is line, N is line, X, 1, and 2 are all banded together with a copper band. Pin 3 goes to my defrost heater. Pin 4 goes to my refrigeration circuit. Again, make sure you take a look at the back of the thing. Okay, defrost timer again, no solenoid, no X terminal. Okay, we have our timer motor, which is connected to 1 and N, and that's a lot of times how you can tell what the N pin is. Look at the back of the clock. You'll be able to see it. And if it's electronic defrost, which is solid state, you'll be able to see very clear designations on the terminals. Okay. So the DTT, which is the defrost termination DTT type, okay, DTT is a high limit switch. The standard DTT is a defrost thermostat. It's set to high temperature to open when the ice has been melted or the coil reaches a specific temperature. The DTT also de-energizes any heaters if it's an electric heat defrost. We want to make sure that the electric heat shuts off if the coil temperature gets too hot. We also have a defrost termination fan delay type. Okay, it terminates and locks out the defrost cycle. In other words, it's the one that allows the neutral or L2 to get back to that clutch solenoid. It's a single pole, double throw, temperature actuated switch that runs the fan in a refrigeration mode and will energize the release clutch solenoid in the DTC, defrost time control, in the defrost mode. So again, when we took a look at the wiring diagram for with a timer with a solenoid, my DTT wires in here. Okay, remember, I'm getting line voltage from that side because normally open has closed and normally closed has open. But on this side, we need to connect it to L2 or neutral. So the DTT is actually in the neutral line of both the evaporator fan and this clutch solenoid. Okay. So when the control terminates the defrost cycle, the EFM, evaporator fan motor, will be delayed until the compressor can make the evaporator cold enough to switch the control back to the EFM circuit. What this does, it prevents a hot pull-down scenario on the compressor. Hot pull-down means hot gas is being returned to the inlet of the compressor. So again, just be aware, just to review, be aware of the differences in the defrost time clocks. You got to pull them out of their case. You have to look at the back of them if you're unfamiliar with what the terminals do. And even someone who's very familiar with the terminals, it doesn't hurt to check. It takes you less than 30 seconds to look at the back of it. So make sure you take the time to do that. And don't mess up the wiring on the X and N terminals because you can actually do damage to a time clock.